guys, happy Tuesday. I hope you're all okay and ready for one of our final online learning maths lessons, hopefully ever. So we are today going to be rewinding another topic. I know yesterday with Mrs. Tilda's we did a bit of rewinding on perimeter. We're going to be using the same process and the same kind of structure all week. So today I'm going to be rewinding area with you, and then we're going to be going on our learning by questions that we used yesterday to see if we can answer some questions and apply that learning that was at the back of our minds, bringing it to the front and then using and applying it. Okay, so the questions that we're going to do first of all are on a slide for you. So we are going to use our knowledge of shape and area. We're going to use it and we're going to retrieve it by retrieving old learning so that we can solve a whole range of problems involving area. So they're going to be asking us different kinds of questions. Some are going to be worded, some are going to be numbers, and we're going to just solve all the problems that we're given about area. Okay, so question number one that we're going to practice. Area can be measured in. Now, I've put this one in here because I know for a fact that in my class, oh no, wait, this was online, wasn't it? Was this online? It was, wasn't it? And in the videos that I did, I know for myself, I don't think I explained this well enough, so we're going to cover it now. So area can be measured in. Now, it's not measured in centimetres or metres. That would be around the edge, okay? It's measured in centimetres squared or metres squared or millimetres squared, whatever you're using, whatever unit, millimetres, centimetres, metres, it's got to be squared because it's not 2 meters along the edge of here, which is not 2 meters, but it's not 2 meters as a one single distance. It's the covering of the whole area, and we can't measure that by going 2 meters, 2 meters, 2 meters, 2 meters all the way down. To measure that whole space, we call it centimeters squared or meters squared, and to do that, you just need that little number 2 after your unit, okay, after your measurement. So centimeters squared, meters squared, millimeters squared, anything squared is absolutely fine, okay? Just depends on what you're given in the question. So that's that one. How can you find the area of a 2D shape that has been drawn on centimeter squared paper? So basically this question's asking, this example here, how could we find the area of that? Could we count the number of squares inside the shape? Could we count the number of squares around the edge of the shape? Could we count the number of squares along the length? 1, 2, 3, and then along the, oh, that's the width, isn't it? So 1, 2, 3 along the length and 1, 2, 3 along the width. Can we find it by adding those? Do we multiply the number of squares in one row by the number of rows? How can we do it? So hopefully you've had a little pause and had a little think about that. And first of all, we know that we can find the area of a shape by, I'm just going to circle the answer, by counting the squares inside the shape, because area is the space inside a 2D shape. So this would be the space inside the 2D shape. Well, that looks better, doesn't it? And it says select 2 answers. It's really important to read that question carefully because it wants us to have another. Now, I know I challenged some of you to work out your area like this, but there's another way we can do it. And even if you're not 100% sure, I want you to pause and get rid of the ones that it's definitely not, and that should leave you one that it might be, okay? So we definitely do not count the number of squares around the edge of the shape. We do not count those squares because that's similar to the perimeter. We're not finding the inside. Count the number of squares along the width and the length of the shape. Again, that's counting squares along the width and along the length, and that's similar to perimeter. Remember, we want the inside of this shape. So by method of elimination, I think this might be our answer. And just in case we haven't gone over this, I'll explain it a little bit for you. Basically, it's like an array. we can do, instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, because some shapes might be huge and some shapes might not have squares. Instead of counting the squares inside, what I can do is I can do 1, 2, 3. So there are 3 there. 1, 2, 3. There are 3 there. If I imagine it as an array, I can see that I've got 3 times 3. And I know that 3 times 3 lots of 3 is 9. And so you can multiply or you can count, okay? And so when we get to some of the other questions, I'd like you to try using both of those methods. So you can count them all, but if that's too much, you can multiply your 2 measurements, and that will give you the whole inside measurement, the whole area. Okay, so what is the area of the rectangle? Now here, I've just added these two so that we don't get confused because some of the answers are the same. So what is the area of the rectangle? Pause and make a note of this for me. So the area of the rectangle, hopefully you've counted those squares inside and you can see that it is 2, 4, 6, 8. There are 8. Now I've got 8 centimetres or 8 centimetres too. And I know that that 2 means squared. So I'm going to go for 8 centimetres squared. Okay, actually, I don't know why I've put these 2 there. Okay, for the next one. Which 2 rectangles have the same area? So these all look very, very different, but we need to find which ones have the same area. And in order to do that, we need to know exactly how big each one is. So by multiplying or by counting, I'd like you to pause the video and just make a note of A, B, C, and D. Just make a note of them like that, and then fill in what each one is. Okay, so we're looking at which 2 have the same area. I have done my calculations, and for question A, I used the multiplication method. I saw that there were 1, 2, 3, 4 going that way, and 1, 2, 3 going that way. So 4 lots of 3 or 3 lots of 4 gives me 12. So I wrote A is 12. And then B, I counted in 2s, 2, 4, 6, 8, 10, that was 10. C, I did multiplication again. I could see that I've got 3. How many times have I got that row of 3? How many times have I got this 3? I've got 1, 2, 3, 4. 5 lots of that 3. So 5 lots of 3 is 15. And then again for this one, for D, I counted in 2s, 2, 4, 6, 8, 10, 12. So now I've got them all written out. I can see that A and D have the same area. Okay, so I had to do 2 things to solve that problem. I had to work out the areas of them all, and then I had to find which were the same. So you sometimes have to do 2 things to solve a problem. Well done. And then next one. What is the area of the rectangle? Okay, what is the area of this rectangle? You can count, you can multiply. It's completely up to you, but I'd like you to make a note of it for me. And the area of this is 14 centimeters squared. Don't forget the squared, because we're finding that area, how much it fills up. So 14 centimeters squared. Now I think this is our last one for today's lesson. And I put it in there because, not because I'm mean, although it might look like it, because you can do this. You need to change how you look at it for a little bit, use what you already know, and also because you might come across it on your questions that are set, okay, or something similar anyway. So which shape has an area of 15 centimeters squared? Okay, so for this one, remember, it's not a regular shape, but you are still counting the squares. We can't multiply for this one because it's not an array. It's not a perfect array, okay? So you are going to need to count. So I'd like for you to have a pause, count, and then tell me which shape has got 15 centimeters squared. I've just worked it out. So, ready for the answer? B has got 15 centimeters squared. And I looked at it because I thought 1, 2, 3, 4. So that's 2 lots of 4 there, which is 8, 9, 10, 11, 12, 13, 14, 15. So it is B that has got 15 centimeters squared as its area. Okay, so I'm thinking that I was going to show you learning by questions online, but I don't think I have a login that will look the same as yours, so I don't want to confuse you. So with today's timetable, we will post a code, and you need to go on learning by questions like Mrs. Tildesley explained yesterday. Go on learning by questions, use the login that you've set up, you should be in our classes by then, and then you can use the code that I give you. Every day you will need a new code, okay? And we will set some area questions for you to have a look at. I might also be a bit cheeky and set some questions to do with maybe history or science. And if you want to have a look at those, then you can. That will be extra. You don't have to do it. But I think if you're on there and you're enjoying using the website, then I'll give you a few extra bits to keep you going. Okay, so have a fantastic rest of your day, and I am very excited to see your scores. It saves them all for me to see your scores on area. Okay, have a wonderful afternoon, and I will see you soon, guys.